It's a continuation of the lecture on risk and return, Lecture 8. Got cut off right at the end of the last video. We were over here on Excel, and I was showing you how to use Excel to get an average and a standard deviation, which isn't too complicated. There's a function called average, so just select your returns, average. I've multiplied it by 12 because these are monthly returns, and it's typical to quote things in annual rates. There's also a function to get a standard deviation. It's STDEV, and then you select it. To gross up a standard deviation from monthly to years, you have to multiply it by the square root of 12. That's a kind of a little minor math issue, but you don't multiply it by 12. You'd multiply the variance by 12, but the standard deviation is the square root of the variance, so you have to multiply it by the square root of 12. So we did an example where we looked at leverage and how that affects your risk and return. More risk, more return. If you want less risk, you have to take less return. And then we've covered kind of briefly average and standard deviation. I'm never going to make you calculate these by hand, so it's just kind of time consuming, and you would never calculate it by hand in practice anyways. You would use Excel or something like that. But we've talked about what an average and standard deviation is briefly. That's called a standalone measure of risk. It works good for a large diversified portfolio like the U.S. stock market, which is what we used in our example. It doesn't work so well for individual investments, and that's because it doesn't consider the benefits of diversification. When you include multiple securities in a portfolio, sometimes they cancel each other's movements out. I actually have a example here. Make this a little smaller so it fits in the screen. Here's a simulated stock price. So it's got an overall expected return, which is the slope, the average of this line, but it's got times when it's a little higher and times when it's a little lower, so it kind of goes up and down as it's moving up over time. So the more this thing swings back and forth, the more risk it has. You can get its average return by averaging, fitting a line through the middle of that thing. This is a real convoluted example, but say there was this is stock A, say there was a stock B that looked like this. So every time stock A went up, stock B went down. And now let's say you combine the two in a portfolio, 50-50, so you put half your money in A and half your money in B. Well, you'd end up with the exact same expected return but no risk. That's again, it's a convoluted example, but it's just to show that there's diversification potential benefits, where sometimes when one stock goes up, another goes down, and they cancel each other out, but they both had a positive expected return, so you're not losing any expected return, you're just removing risk if you diversify. In real life, it's not quite as perfect as this example, but there is definitely diversification benefits. Let me scroll down. We're going to do a little example here to show maybe a little bit more realistic scenario. So in this example, we have a portfolio with two stocks, stock A, stock B, and then I've given you some metrics of risk and return for the two stocks. First off, I give you the weight. So in this case, we're not 50-50. We have 25% of our portfolios in stock A and 75% in B. And you could extend this out to have many more than just two stocks. It's just a lot easier to do by hand when you only have two stocks. So it's just for the example, we're just going to use two stocks. Both of them have an expected return, and both of them have a standard deviation. So it's 10% for A, 12% expected return for B, 20% and 25% is their standard deviations. And then lastly, I've given you a correlation coefficient. That shows you, I'm not going to go in the math of correlation, but it's a number between -1 and 1. If it's close to 1, that means they're very highly related to each other. When one goes up, the other goes up, and vice versa. If it's close to -1, they're the opposite. So when one goes up, the other goes down, and vice versa. Like that example I just showed you on Excel, those would have been -1 correlated. Every time A went up, B went down, and vice versa. I want you to calculate the portfolio's expected return and the portfolio's standard deviation. And I've done all that for you here. What's the portfolio's expected return? It's just a weighted average of the two returns. So in this equation, I have the expected return. One way to denote a mean or an average mathematically is just to put a line over the top of the number. So this is the average return of the portfolio. So return of P is return of the portfolio. Return of A is the expected return of stock A. Return of B is expected return of stock B. And I put 10 and 12%. I just took them out of the table on the previous page. Then I put my weights in there. It's a weighted average, meaning we're not straight averaging. What's the straight average of 10 and 12? It's 11. Well, the answer to this is 11.5. Why? That's because we're weighted a little heavier towards stock B. 3/4 of our portfolio is in stock B. The weights have to add up to 1. And again, you could extend this out if there were more stocks. But again, the weights would all add to 1. And then you'd put the expected return for each of your individual stocks in there. Run your weighted average and get the expected return on your portfolio. So expected returns are mathematically linear, we would say, or additive, meaning that you can just do a straight weighted average. When we go to do the standard deviation, that's not going to be the case, and that's going to be because of diversification benefits. What is the portfolio standard deviation? Well, I've written in here what you might think to do, which is to do just a weighted average, but I put a does not equal sign in there. If you just do a straight weighted average of the two standard deviations of the individual stocks, so stock A had a 20% standard deviation, stock B, and by the way, you use sigma to denote standard deviation, the Greek letter sigma, sigma for S for standard deviation. But, excuse me, I assume you've seen that in a stat class or something before when we were talking about the normal distribution or something like that. So, but if we did a straight weighted average, like we did with the return, you'd get 23.75% standard deviation, but that is not the right answer. Make sure you note that is not right. This is actually the formula you have to use. It's almost a weighted average of the variances. So if you squared everything, that would make it the variance. And here we have the weight of A squared, the standard deviation of A squared, the weight of B squared, standard deviation is B squared. But then we have this other term in here, and this is for diversification benefits. This accounts, there's a correlation coefficient over here. The lower that correlation coefficient, the more diversification benefits you're going to get. If this is 1, well, it's just going to end up being a weighted average of the two individual standard deviations. But as long as the correlation of the two assets isn't 1, there's going to be some diversification benefit. It's going to lower this whole right term here by this factor, which in our case was 0.2. And so the actual correct answer is 19.9% standard deviation, which is less than if you were to do just a straight weighted average. Why is it less? It's less because of diversification. There's times when A goes up and B goes down and they cancel each other out. But note, you haven't lost any expected return. Your expected return is still just a straight weighted average of the two individual expected returns. But because of diversification benefits, the standard deviation isn't as high as it would be if it was just a straight average. So in summary, diversification lowers your standard deviation without lowering expected returns. And then the implication is, if you can remove risk without removing expected returns, then if we assume that all our investors that are setting market prices are large investors that hold diversified portfolios, they're going to take advantage of all those diversification benefits automatically because they have large portfolios that are well diversified. If that's true, then they're not going to care about risks that can be diversified away. They're only going to care about risks that can't be diversified away, non-diversifiable risk. We call that systematic risk, if you want to get into definitions in the textbook. There's unsystematic risk and there's systematic risk. Unsystematic risk can be diversified away. Systematic risk, sometimes also called market risk. In fact, I think your textbook calls it market risk. Other textbooks call it systematic risk. That can't be diversified away. There's actually a chart in your textbook, which, let me center this. This is not the right one, sorry. Let's scroll up. These are all the charts out of your textbook. This is the one I want to look at here. Sorry about that. As you increase on the x-axis, they have the number of stocks in your portfolio. If you only have one stock in your portfolio, you're taking a whole lot of unsystematic risk you don't need to take that could be diversified away. As you increase the number of stocks, your standard deviation in your portfolio goes down, but there's a certain point where it can't go any lower because you're fully diversified. There's no other stocks out there that aren't, if you want to get into the math of it, at some point, every stock you add to your, let's say you already have 1,000 stocks in your portfolio. If you add one more, it probably doesn't add any diversification benefits because its returns are actually probably already captured by a combination of stocks that are in the portfolio. Meaning you could, it's a linearly related to some group of stocks that are already in the portfolio. So you're not really adding anything. You're adding another stock, but it doesn't decrease your portfolio standard deviation. So there's some point where you can't diversify anymore, and there's a minimum standard deviation. That minimum standard deviation you can't lower. You can lower it by levering up or levering down, like we showed in that first example, but you can't go above or below the blue line, meaning if I go back to this and scroll over, so we showed with the stock market, fully diversified portfolio, this is the whole U.S. stock market, so it's fully diversified. We showed there's a risk and return trade-off, but the point is you can't get above the blue line. There's no way, if you wanted to have, so the actual market was right here, which had about 15-16% standard deviation. If you want to have 15-16% standard deviation, you're going to get about 10% expected return. You can't go up and diversify more and get 10% expected return with less risk, is what that's saying. Basically, you can't get anywhere up here in this quadrant. You can get down here, but that's bad. That means you're taking more risk that you haven't diversified away. If you fully diversify, you end up on this blue line, is what we're saying. So you can take more risk and get more return, but you can't get, for your return, you can't get even, or for your risk, you can't get any more return than that. So that's means you've fully diversified. You've got yourself to your minimum standard deviation that's possible. And now let's go back to our notes here. It says in here, investors are only compensated for holding non-diversifiable risk, meaning you don't get paid anything for holding risks that can be diversified away. Compensated means you should, if you take more risk, you should get more return, but you're not going to get any more return for taking risk that can be diversified away. So not all risk increases returns. If you want to get more returns, you have to take more risk, but just because you take risk doesn't necessarily mean you get more returns. It's a one-sided relationship. I wrote it up here in the notes, way up here, sorry, where more risk means you have to take more return, but you can't flip that around. If you take more risk, that doesn't apply necessarily that you get more return, because there's only certain risks that you actually get compensated for. The only risks you get compensated for are ones that can't be diversified away. So the people who are setting market prices, the large institutional investors, hold well-diversified portfolios, and so when they set prices, they're setting them on risk that they are taking, not risks that if you go out and buy an individual stock, you're actually taking quite a bit more risk than they're taking because you're not getting any diversification benefits. All right, so the next thing we're going to talk about is the capital asset pricing model in beta. Beta is going to be our measure of non-diversifiable risk. This capital asset pricing model is called a one-factor model. It's a very basic model, and there's also 3-factor, 4-factor, 5-factor models that are more complicated, which we might touch on just a little bit right at the end of our lecture here. But this is a starting point. It's a good place to start to how can we measure non-diversifiable risk. This is a good place to start because it's the simplest, easiest to understand. I'm going to go ahead and end this video. We'll switch over on Lecture 8.3 and we'll finish there. Thanks.